So for this problem, we're looking at an ICP-MS spectrum. Since we're using an ICP, we expect to see atoms and their isotopes. We can directly identify these peaks by using a table that shows the masses of the atoms and the masses of their isotopes.
So, as we're going through and identifying these MS peaks, we need to take into account the relative abundances of each of the isotopes. Let's look at the potassium peaks around a mass of 40 daltons. So we have those three peaks labeled as potassium 39, potassium 40, and potassium 41. But if we look at the relative abundances of the potassium isotopes, we see that the potassium 40 isotope has a much smaller abundance than the potassium 41. And this doesn't make sense with the way we've labeled it, because the potassium 40 peak is higher than potassium 41 peak. So, utilizing that information, we know that we've labeled the 40 peak incorrectly. Upon further analysis, it becomes obvious that the peak at 40 daltons corresponds to argon 40. The ICP mass ionizer utilizes argon as a plasma source, so we should expect to see argon 40 on our MS spectrum. The identification of the rest of the peaks is straightforward. The biggest thing to remember is to identify isotopes and utilize their relative abundances in doing so.